Okay, now you should see SweepMe. I already opened it. So if you open it, it looks maybe like this. We can go here to the sequencer tab, and we want to make our first measurement. In the first step, I will clean, although will remove everything here, so that it is really just a free and new SweepMe. So I want to measure an IV curve, and I have here one source measuring unit. This is a 4-channel. Oh, sorry. It looks like that I have this. But anyway, it is a 4-channel SMU, and I will control it to measure an IV curve. So what I do is I add an SMU to the sequencer. I double click on SMU, or I go here to the tab, and I select, as the first step in the SMU module, I select the driver. This is the ID SMU from Aspect Systems. I click Find Ports, and now I can see all the ports that this instrument or that the driver can find for this instrument. My LED is connected to channel 1, so I select channel 1. In the SMU module, you have a section where you can define the sweep that this module is doing. You can decide in the sweep mode whether you want to vary a voltage or a current. We want to vary a voltage for measuring the LED. And the second step is that you choose where the value does come from. It can come from internal sources of this module, but it can also come from external sources. For example, you can hand over a value from a recipe file or from another module, and this allows you also to make more complex things in SweepMe. For now, I will use the sweep editor, and the sweep editor is part of the SMU module here in the sweep values tab, and I will create one IV curve. I want to make one loop from -3 to 3 with 0.05 steps. I can make a right click on the sweep editor, and what I see is the values that are generated. I have a step width defined with 0.05, and I have 121 values from -3 to 3. If I want to make a dual sweep or a back sweep, I can just add another line and mirror or revert the direction of the sweep from 3 to -3 in 0.05 steps. Again, I can check what I have generated, and now we have 242 values going on. Before I start my measurement, I can add already some widgets. This can be done here in the menu widgets. I can add different widgets. I will add a plot. And the plot can be by drag and drop moved into the dashboard. And you see this blue drop indicator area, and where the blue area is, the widget will drop into it. If I double click the plot, or I go here to the option configuration, I come to the plot settings. And here in the first tab values, I find all my modules. I find the SMU module, and I want to plot the current over voltage. You can also see that there is a time module. The time module is an inherent part of every sequencer, so you cannot remove the time. Time is always there, and time will always be measured with time span and the time elapsed and so on. So, okay, we're ready. Measurement is started. And here you can see the IV curve. And measurement has finished. You can again go into the plot settings and change the scale to logarithmic. And we have an IV curve measured. So basically, you only added one module, which was the SMU module. SweepMe automatically adds the make file module because it wants to make sure that you save your data. If you don't want to save the data, you can also switch off the make file. But here we want to save the data and have the measurement data. Let's see how it looks like with the measurement data. I can go to Open Folder, Temporary. And the temporary folder consists already all the data that we created during the measurement. I open this text file. And what you see is that SweepMe added from the time module, time elapsed and time stamp. And from the SMU module, it adds voltage and current in a tab separated text file that is easy to load with any evaluation software. And additionally, you can find in your temp folder a settings file. And this setting file consists of the complete configuration of SweepMe, including the configuration of the sequencer, all modules, and also the widgets. So this setting can be used to restore the entire measurement again, and as part of every saved data. If you now want to save your data, you go to the General tab, you add a name for the folder, and the file name, let's say test and web seminar. Now I save data. And what SweepMe is doing, it copies the data from the temporary folder into your final measurement folder. And there is one place in the public documents folder where for each user, a profile is created with your data. If I click on this, I can easily come to this folder. And now you see the files are renamed. We have the setting file, we have the data file, and SweepMe also saves a thumbnail of the plot so that you can easily see your measurement data. It has a transparent background. This is why it is black in the background, but basically you have a thumbnail of your data so that you can quickly understand which data was saved here. If you now want to extend the measurement, you can now add another SMU. And I want to use the second channel of this SMU because it has 4 channels. I take again the Aspect Systems ID SMU. I click Find Ports. I go to my second channel. And now I configure the second channel to stay at 0 volt and don't make a sweep. So if you just want to have an instrument that runs at constant conditions, just make a sweep with a single value. And what we can see here is a sweep with 0. And it means if you have a sweep over one value, it's a constant value. And this means that SMU runs through different voltages and SMU2 just stays at 0 volt and tracks whatever it can do. I have connected a solar cell to the second channel, which you probably, now you can see it. And to plot the value of the second SMU, I can move it to the Z axis. This is the right axis in SweepMe. And let's run the measurement. And you can see it tracks here a current and here a voltage. Voltage, yeah, should actually be okay. I'm wondering that with no light is tracked here, but you can see it is still measuring now 2 different values. You can further expand the setup by adding more and more modules to higher or low variation or to add branches to make one measurement after another. The next step that I want to show you in the software is how to activate a driver or a module. Because when I was going to the SMU module and I selected this driver, this is because this driver is already installed in my system. But in your system, in your SweepMe installation, it might be that the driver is not available yet. So what you can do is you go to Tools, Version Manager. And the Version Manager opens. I will have to move it to the presentation screen. It's currently loading and updating from the online versions. So now it is ready. And in this tool, you can find all the modules. These are these bold, bigger ones. And sometimes they have these nested items, then these are drivers. So if I want to find the IDSMU driver, I type in IDSMU. I go to my SMU module and I can find here Aspect Systems IDSMU driver. And now you can see that I have multiple local versions like repo, multiple versions from 2025. And there's also an online version. If I go to this online version and click Activate Selected Version, it asks me, do you want to replace your current version? Because I already have exactly this version installed. I say yes. And now this version is activated. I can jump at any time to a different version or also load drivers from a repository, for example. And this is how you can activate a driver just by searching for it or going to our webpage and finding the drivers there. And then you know that you can also download them here. And the same thing holds true for modules. Also, modules can be updated by downloading a module version. And with this system, we can, for example, improve the SMU module without the need to reinstall the entire software. Okay, let me check what else could be very interesting. So the widgets I want to show you as well. I already showed you the plot widget, but we can now, for example, also add a monitor widget. And put it here. And with that, I create my own visualization. Maybe let's add the time and here voltage and current. I can run again the measurement. And now you can see how this monitor is updating values during the measurement. Okay. If you want to save your program flow, you can do this with a setting. This means you go to Settings, Save Setting, and it is possible to override your test setting, or you can save it as a new file with save setting as, of course. And then you can define a file and save it here. When you reload this file, you get exactly this measurement as configured, and you can directly press run to start a measurement. Now I also want to show you a bit, very briefly, the driver scheme. Here we can click open modify, and we can open the driver. So everybody can check the source code of drivers and see how they are created and how they are done. So basically, it is a Python file. We try to release them under MIT license so that everybody can use them, also very easily for commercial purposes or for own projects. And the driver is at the end nothing else than a Python class with a lot of functions where we define, for example, variables and units. And then we have a structure with what we call semantic phase functions. These are functions like connect, disconnect, initialize, configure, or unconfigure, power on, and so on. And these functions are not related to a source measuring unit or related to a spectrometer or to a monocreator. They are very generic and describe the generic steps of each measurement. So every instrument must go through these phases of a measurement, and also the sequencer has to go through these phases. And what we do in our driver scheme is that the programmer of a driver adds at the correct positions what the instrument should do in the unconfigure phase and the configure phase, or in the apply phase where we set a new set value, or in the measure phase where we call data from the instruments and collect the data. And with this scheme, it is possible that all these drivers immediately work with each other because they run through the same phases and do at the correct phases the correct steps to control these instruments. There is one question in the chat.
There's 2 questions already in the chat.
Okay, then we start.
Are you finished with the presentation?
Yeah, we can go over to the Q&A session. I can read the first question. Can SweepMe control devices through a microcontroller unit such as an ESP32? I have no idea if it works as an SMU. Yes, this is possible. If you have something like a microcontroller like ESP32 or Arduino, you can program the Arduino or the microcontroller in a way that it accepts commands. We have a very nice example for this. I take a switch module and I select the stepper motor driver. This is a driver which can send commands to an Arduino, and the Arduino is programmed to control a stepper motor. If I open modify the code, you can see that we have again these commands like initialize, deinitialize, and these semantic functions. And then there are specific functions where we write, for example, MT to the Arduino, like what is the motor type, or get the target position is TP. And on the Arduino side, if I go to my version manager, I can search for this driver. Just need to wait that it updates the contents from the server. And I can here go to motor stepper. No, it's called stepper motor. And if I, this version, for example, let's activate this. And let's open the folder of the version, open version folder. We can see that this driver comes with an ini file, an Arduino file, and this is exactly the file that you have to upload to the ESP32 or to the Arduino, and then the Arduino understands exactly the command. This means you have to program your microcontroller in exactly the way that it can understand your commands and control something. So it means for each driver of SweepMe, you need an individual Arduino file or firmware file to handle your communication. Let me know if there are any follow-up questions. The next question is it possible to have a live view of a connected measurement device like spectrum analyzer, oscilloscope, or network analyzer? And furthermore, is it possible to start a calibration within SweepMe, or is it on the roadmap? What you can do to make a live view is we don't have an indirect live view in terms of you open a widget and you see automatically an updated plot and values from this, but you can create it as your own routine in SweepMe. For example, you can put a loop module into the flow. I go to the loop module and put it to 0, which means use 0 for endless and non-stop. And you can add a delay module. And this delay simply makes sure that we don't call too often data from the instrument. For example, it is okay for us for every 0.2 seconds. Now I can change my SMU to also constant values. Let's add a new line. This is read out as 0 volt. I will switch this to 0, that they are not used anymore. If I run this measurement now, I have two SMUs that run at a constant voltage, like they are like a sensor or like the data from an oscilloscope or spectrum analyzer. And if I click run, what you can see now is that it plots the data. And I want to show the data not over the voltage, which has some fluctuation, but I want to show it over time. And now you see some kind of live plot, including a monitor that shows the latest values and how it is proceeding. And if you have an oscilloscope, you can also plot two-dimensional or one-dimensional data. It is further possible to slice and filter your data. The slicing and filtering has to be done for the module that makes the variation. For example, we can also say, please show me from the last 10 values to the end. So the syntax is from Python. And if I click OK, you can now see that you have such a moving thing over time, that you only see the latest 10 points. And this can be also done for oscilloscope, that you say, please show me only the latest waveform. And then you see an update of the waveform that is constantly called from the instruments. The second part of the question was, is it possible to start a calibration within SweepMe, or is it on the roadmap? Such things can be included with add-on modules. You can add a custom function module where you can run your own Python scripts and do very specific things. So at the moment, it is not included into the network analyzer module, let's say, to have a button like calibration. I think this is a very good idea to add this also. If I here, for example, add a network analyzer module, and I go here, there could be, for example, a second tab, which is dedicated to calibration and has some features for this. But at the moment, what you can do is you can run a custom function module. And custom function is an add-on module where you can run very specific Python code and get data from your system, do some manipulation of the data, return post-processed data, or write also something to instruments where you can customize your sequencer further and, for example, write a calibration routine if this is needed. If there are follow-up questions, please feel free to ask further questions. Then, thank you so far. Can old data from a SweepMe created log file plotted again, maybe also with an analog scaling within the widget? Yeah, okay, this is a question that we had sometimes. It means the question is a bit like we make a complete measurement and we store the measurement, including the setting file and all the data. And then when you load the data again, or when you load this container of data and setting again, that you have exactly the same situation like after you did the measurement where you can still manipulate the data. For example, now I did a measurement here. Let me remove these two widgets, these two modules. I can still change here, for example, at any time the plot, even after the measurement, and now investigate my data. But once SweepMe was closed and I opened the program again, I cannot just immediately load the setting and the data again and have the same situation. So this is not possible right now. The only thing that works is that you can use the add-on module read values. And read values is a module to get data from recipe files or from Excel files. I can, for example, do select file and take, for example, here an Excel file that I have created for a motor control. And now it is possible to read in the data. And once you sweep through these files or through this data, it is handled like if it would be measurement data, if it would be data from an instrument that is returned. So it behaves always the same. So it is, for example, possible to load a measurement data file from SweepMe and run through it, and then you can plot it again. But it's definitely not maybe what you were looking for, but this is maybe a first attempt how you can also do post-processing of data in SweepMe by running through files and post-process them and create, in general, program flows in SweepMe. But I will take your idea also into our further consideration of new features that we could add to SweepMe. And we definitely would need a good concept for this, but it's a very interesting thing to also add such things. If there's a follow-up question, please also ask. Can you give me some idea? I am using LabVIEW software to control vibration shaker and get the vibration sensor data. How this could make automate with SweepMe? we have currently, I have, let's say, in contact with an institute that is doing very similar things like vibration shakers and such things. And at the end, you need to create instrument drivers. So you have, for example, a shaker. Prominent company for shakers is, for example, the company Spectra. And if you have a Spectra shaker, you can create a driver and tell the shaker at which frequency it should shake and maybe with which strength it should shake. And such a driver could maybe be created for the switch module. The switch module is a very generic module that can implement every instrument that does not fit into the other categories like SMU or robot or network analyzer. So here you can implement everything that is, that you want to implement. And we would probably create a shaker driver for the switch module. And as I showed you for the stepper motor, it can come with its own custom parameters so that you can exactly configure it to your needs and then run sweeps through your frequencies and also add other instruments that maybe collect data from things that you want to shake and to analyze. This would be the way to do this. Is there a follow-up question? Then please feel free to add it to the chat, or you can of course also